Alright, there seems to be a little bit of a typo. It says the following are the 5 molecular orbitals of the 1,3,5 hexatriene. There's actually 6 because there are 6 p orbitals, so there are 6 there. Which one best represents the HOMO? The orbitals are listed in a random order. Well, first thing I would probably do is figure out what the order is from the lowest energy to the highest energy. And the way you do that is you look for nodes. In A, we have one node there, one node there, one node there, and one node there. That's where you have opposite phases next to each other. And so this is 4 nodes. B, they're all in the same phase, so that's 0 nodes. C, 1, 2, 3 nodes. D, 1, 2 nodes. E, 1, 2, 3, 4, 5 nodes. F, just the 1 node. Now, next thing we do is figure out how many electrons there are. 1,3,5 hexatriene has 3 pi bonds. That means we're dealing with 6 pi electrons. And so we fill them in from the lowest energy to the highest lowest energy and then on up until we used all 6 electrons. And so 0 nodes has the lowest energy, so we put 2 electrons there. 1 node has the next, 2 electrons there, so we're up to 4 electrons. And then 2 nodes is here, that's 6 electrons. And then we're out of electrons. So this one right here, D, has electrons in it, and it is also the highest energy, so this is the HOMO. The LUMO is the one with the lowest energy that's empty. So we have 3 that are empty, A, C, and E. The one that's lowest energy would be C, so C, if the question was asking for the LUMO, would be that one. That's one way of doing this question. The other way of doing this question is this right here has an even number of carbons, an even number of p orbitals that are conjugated to each other, right next to each other. And when it's that way, the HOMO is the easiest one to draw. You just put p orbitals next to each other, and then where there's a pi bond, you shade appropriately. Where there's not a pi bond, you have a node. And you can see that this matches D. That's a quick and dirty way of figuring out what the HOMO is, but that works only on this set of conditions right here. When it's an even numbered of carbons.